Hello students, this is your Kirti ma'am, and as a part of board revision for the year 2026, let's start revising the concept in the best way by doing the PYQs for the most important chapters for chemistry. And today we have taken such an important chapter, like there is a very good weightage for this chapter when it comes to MCQs and even the theory exams. Now, if we focus on the last year MCQs which came from the chapter metals and non-metals, let us try to do them and approach them in the best way possible so that it will be useful for you, to approach new questions with respect to this chapter. Okay, let us do the questions. Let us solve the MCQs. If you observe the year 2025, we had 4 MCQs from the chapter metals and non-metals, which is a pretty very good number of MCQs from chemistry. Okay, let us start solving them. First question, if you see, the question is the products formed when aluminum and magnesium are burnt in the presence of air respectively are. So he is basically talking about burning of metals in the presence of air. So that is nothing but oxygen, because oxygen is the most reactive gas present in the atmosphere. So if you take here, aluminium is burnt in the presence of air, which we are taking here as oxygen. So what does aluminium plus oxygen give? It gives her aluminium oxide, Al2O3. We'll do the balancing also. It will be a good practice of the reactions. Here 2 oxygens I have and here 3 oxygens. So I'll put 2 here and I'll put 3 here. Okay, now I got 4 aluminiums here. So it will be 4Al plus 3O2 gives 2Al2O3. Let us write the physical states. Aluminium is in the solid form. Oxygen is in the liquid form. Then aluminium oxide. All metal oxides physical state should be solid. Always remember, all metal oxides physical state should be solid. So this is my reaction. Then he's talking about magnesium. Magnesium burns in the presence of oxygen, giving magnesium oxide. All metal oxides are solids, as I told you. So magnesium is a solid here, oxygen is a gas. Now let me try to balance it. 2 oxygens here. So I'll put 2 here. Now I got 2 magnesium atoms. So here I'll put 2 Mg. Okay, so this I think I already got my answer. So it should be Al2O3 and MgO. So it should be option B. Okay, whenever we do any question, we'll try to add few important points regarding that question. Okay, if we talk about Al2O3 and MgO, okay, these two are the protective oxide layers. They protect the inner layers of metal. They protect the inner layers of metal. No, to, see, for example, if you take this is aluminium. Aluminium, no, the outer surface of aluminium is exposed to air. So that outer surface will react with air and form an oxide layer. Now this oxide layer will protect the inner layers of the metal. Okay, already you have an outside aluminum oxide layer. That outside aluminum oxide layer will take care that the inner aluminum is not spoiled. So it is like self-protection. Okay, aluminum forms its own oxide layer, which in turn protects it from undergoing further corrosion. Okay, in the same way it is with the magnesium oxide. There is one more important point regarding aluminum oxide. You should always remember aluminum oxide is an amphoteric oxide. So whenever we do any question, we'll see other important points also regarding that question so that it will help us for the examination. Okay, if you see the question 2, no, hopefully the question 1 is clear. I have shown the reactions and the respective balancing also. Let us take the second question here. Okay, here if you see the second question, it is given reaction between two elements A and B forms a compound C. So I have two elements which react to form compound C. He is saying A loses electrons. Okay, B is gaining electrons. So if an element is losing electrons, it will form a cation A plus, and if an element is gaining electrons, it will form an anion B minus. So this is my cation and this is my anion. And there will always be an attractive force between the oppositely charged ions. The force of attraction between oppositely charged ions, what do we call it as? Electrostatic force of attraction. The force of attraction between two oppositely charged ions, what do I call it as? I call it as electrostatic force of attraction. Okay, so between cation and anion, what do I have? Electrostatic force of attraction. And due to this electrostatic force of attraction, a bond is formed between both of them. And what do I call that bond as? I call that bond as ionic bond. And the compounds which are formed as a result of ionic bond, I call them as ionic compounds. I call them as ionic compounds. Now, if you, as you people are aware that, okay, cations are usually formed by metals and anions are formed by non-metals. So, ionic compounds are usually a combination of metal and non-metal, where metals are giving the electrons forming cation and non-metals are gaining the electrons forming anion. Now, it is very important for you people to remember the properties of the ionic compounds. The first very important property of ionic compounds are they are mainly solids. Okay, these solids are hard and brittle. Very important, brittle. These solids are hard and they are brittle. Okay, second important point you need to remember, ionic compounds have high melting and boiling points. Now, why do they have high melting and boiling point? As I told you, due to the strong electrostatic force of attraction. Next very important point, they, okay, ionic compounds are soluble in polar solvents. Okay, because like dissolves like. Okay, ionic compounds have polarity due to charges, so they will be soluble in polar solvents, okay, which also have the charge formation. Okay, next one. Okay, in solid state, they don't conduct electricity. Okay, they don't conduct electricity. The ionic compounds don't conduct electricity in the solid state, but in the molten state, they do conduct electricity. And also in the aqueous solution form, also they conduct the electricity. Now, whenever I say they conduct electricity in molten form and aqueous form, why do they conduct electricity in molten form and aqueous form? Because in molten form and aqueous form, what do they have? They have the free ions. In molten state and aqueous state, they have the free ions. And in chemistry, free ions conduct electricity. Free ions conduct electricity. So these are the general properties of ionic compounds which you need to remember. Now let me check the options. He is saying which one of the following properties will not be shown by the ionic compound C. It has high melting and boiling point. Yes, it has high melting and boiling point. It is highly soluble in water. Yes, it is soluble in polar solvents like water. Next, it has weak electrostatic force of attraction. No, it has strong electrostatic force of attraction, because of which it has high melting and boiling points. So C option is wrong. Okay, the option would have been correct if it was written it has high electrostatic force of attraction between its oppositely charged ions. So the answer is option C, which is wrong. We'll see option D too if it is correct or wrong. It conducts electricity in the molten or aqueous solution. I already told you it conducts electricity in molten or aqueous solution. So the correct answer and the incorrect statement in the following options is your option C. Now let us go for the question 3. If you go for the question 3, the question 3 says that the metals obtained from the metal chlorides by the process of electrolytic reduction are. Now, before going further for this question, let us quickly see the, extraction process of, all the metals in the reactivity series. Now, you people know that categorized, all the metals are categorized into low reactive, moderately reactive, and highly reactive. Now, if we quickly see the low reactive metals, okay, if we quickly see the low reactive metals in the Earth's crust, their ores are usually sulfides. Now, what do we do? We convert the sulfides into oxides and then we do the reduction of oxides. Okay, then we do the reduction of oxides. Now, when we convert low reactive metals from their sulfides to oxides, now I have to do reduction of oxides to convert them into metal. Here, how is the reduction done? Just by heating. Okay, step by step, low reactive metals are obtained as sulfides in the Earth's crust. Now, first I'll convert sulfides into, okay, sulfides into their respective oxides. How do I convert sulfides into the respective oxides? By heating in the presence of oxygen. Now, after converting them into oxides, now to convert the oxides into metal, I have to do reduction of oxides. How do I do the reduction of oxides for low reactive metals? By just heating them. Now, then I have my moderately reactive metals. Now, the moderately reactive metals are obtained as sulfides in the Earth's crust. You can see them in the form of sulfides and you can also see them in the form of carbonates. Now, if it is sulfides, what do? We do the process called roasting and convert them into oxides. Then what do I do? Then I do the reduction of oxides using carbon or carbon monoxide as a reducing agent. You will ultimately get your metal after reduction. Sorry. Okay, you will ultimately get your metal after reduction. Okay, clear? Now, okay, if you go for the carbonates, what do? I convert carbonates into oxides by using a process called calcination. Now, I'll do the reduction of these oxides, which I got from carbonates by doing what? Calcination here. Okay, calcination here. And here, what do you do here to convert sulfides into oxides? I do a process called roasting. Okay, roasting is heating of sulfides in the excess of oxygen, forming their oxides. Now, calcination is heating of carbonates in the limited supply of oxygen. Now, reduction here also we do reduction using carbon or carbon monoxide, and oxides get reduced to metal. And what is the reducing agent I'm using here? You can either use carbon in the form of coke, or you can use carbon monoxide as the reducing agent. Now, when we go for the highly reactive metals are usually obtained as chlorides and oxides. Now, the problem is we can't do the reduction of chlorides and oxides. Okay, I can't do the reduction of chlorides and oxides using carbon or carbon monoxide, because if you see the highly reactive metals, these metals form bond with either chlorine if it is chloride or oxygen if it is oxide. This bond is very strong, and metals have more affinity towards forming bond with chlorine and oxygen. Now, carbon doesn't have that much affinity towards metal as chlorine and oxygen have with highly reactive metals. So metal would never want to, highly reactive metals would never want to lose the bond with chlorine or oxygen and form it, okay, and react with carbon. Okay, and react with carbon. So carbon is not that good reducing agent that it comes and breaks, okay, the breaks this bond and reduces metal chloride into its respective metal. So the affinity of metal towards chlorine is more than carbon. That is the reason carbon, it cannot be acting as a reducing agent if in case of metal chlorides. Okay, that's the same thing applies to metal oxides. If this is the case, then what is the method I use here for the reduction? So here I convert metal chlorides or metal oxides into their respective metals by reduction. And what is the process I use for reduction here? The process I use for reduction here is my electrolysis process. The what process I'm using here? It is my electrolysis process. So clear? So electrolytic reduction is done for which metals? We do electrolytic reduction for highly reactive metals. Now, if you see the options here, first option A is gold and silver. Gold and silver are low reactive metals. Option B is calcium and magnesium. Yes, calcium and magnesium, both of them are highly reactive metals. So it is option B, but still we'll check the other options too. Aluminium and silver. Aluminium is a highly reactive metal, but silver is a low reactive metal. Sodium and iron. Sodium is definitely a highly reactive metal, but iron is a moderately reactive metal. So it will be option B. So answer for my MCQ 3 is my option B. Now let us go for the fourth MCQ. Okay, if you look at the fourth MCQ, the formation of magnesium oxide is correctly, okay, the formation of magnesium oxide is correctly shown in the option. Now he's basically showing the ionic bond formation. Metal gives electrons and non-metal takes electrons. Now here I have magnesium here. Okay, here I have oxygen. How do you show the ionic bond formation here? Using the Lewis dot structures. Okay, now Lewis dot structure means what? I have to represent the valence electrons of that particular metal or non-metal. Now if you take magnesium here, magnesium atomic number is 12. Okay, so if you see the arrangement of electrons here, it will be 2, 8. Okay, in K shell you can fill 2 electrons, in M shell you can fill 8 electrons, and in L shell, in K shell you can fill 2 electrons, in L shell you can fill 8 electrons. So the remaining 2 will go to M shell. Now magnesium wants to lose these 2 electrons in the M shell, because if magnesium loses these 2 electrons, then L shell will be its outermost shell, and L shell will be completely filled. Any element will want its outermost shell to be completely filled. So if magnesium gives this 2 electrons, its outermost shell is completely filled. So magnesium has 2 valence electrons and it would want to give this 2 valence electrons. Okay. Sorry, here he has represented magnesium with dots. So let me also represent magnesium with dots. Okay, now oxygen. Oxygen has how many valence electrons? See the electronic configuration of oxygen. It is atomic number 8. So K, L, M, N. Okay, 2 electrons in the K shell, because K shell's maximum capacity is 2 electrons. It is 6 electrons in the L shell. Now outermost shell has 6 electrons, but L shell wants to get fully filled. If L shell wants to get fully filled, it needs 2 more electrons so that it gets 8 electrons in its outermost shell. Clear? Now, oxygen needs how many electrons? 2 electrons. So, oxygen has how many valence electrons already in its outermost shell? 6. So, how many does it need to get fully filled shell and get the stable electronic configuration? It needs 2 electrons. And magnesium is there happily to donate how many electrons? 2 electrons. So, magnesium will give its electrons very happily to oxygen. Now, magnesium, after giving its 2 electrons, it has lost 2 electrons. So, positive charge dominates in the atom. Because it has lost 2 electrons, it will become Mg2 plus. And if I go here, oxygen, which already has how many valence electrons? 6 valence electrons, and it has taken 2 valence electrons of magnesium here, and now it got completely filled valence shell of 8 electrons. As oxygen has gained 2 electrons, I will put these 2 electrons in the square bracket. Any charge should be kept inside the square bracket only. Okay, if you are representing charge, that should be written inside the square bracket. So this is the formation of magnesium oxide. Now, if you see here option A, I think it is right, because magnesium is losing 2 electrons and oxygen is gaining 2 electrons and getting 2 minus charge. So the correct answer should be option A. Option B, what is the mistake in option B? Because the valence electrons of magnesium should be 2 and it is shown only 1 here. If you go to option C, magnesium is giving 2 electrons, that is fine. But only single oxygen is enough for me to take 2 electrons. I don't need 2 oxygens to take those 2 electrons. If you go to option D, single oxygen is there. A single oxygen needs only 2 electrons, but 2 magnesium atoms are there, so 2 magnesium atoms will give altogether 4. But oxygen doesn't need 4, it only needs 2 electrons. So what is the correct option here? A. So these were the MCQs which came in the board exam 2025 for the subject science. Okay, in the next session, I'll solve the theory questions for in the same paper, so that you will have a clear understanding of how to go with the theory questions too. Hope you understood each and every MCQ and the way we are approaching the MCQ. Okay, keep watching all my videos and keep loving our videos. Till the next video, it's Kirti ma'am saying bye to you. Bye.